Hello everyone, so welcome back to another session on network theory, and this is going to be day 2. So you can start counting the day now, right? So day 1 has been successful, right? We have done a kind of introduction to electrical circuits, right? We discuss about various things, right? We discuss about various electrical components and how do we measure current and voltage and so on and so forth. And we discuss about some of the equipments like KVL and KCLs. Okay, in future we are going to use them in many occasions, right? So good afternoon everyone. Yeah, good afternoon Tomby. So please join so that we can start the session, right? So this session is going to be a very interesting session where you will learn everything again from the scratch onwards, right? So today is Diwali, so happy Diwali to everyone. And this session will be for 1 hour, right? Again, and if needed, again I will conduct third session, right? So, and then we will conduct PYQ session where I'm gonna take all the PYQ from electronics and communication, electrical engineering, as well as instrumentation. Okay, whatever concept we are learning, we will be applying them in our PYQs, right? So you don't have to solve those kind of questions which are very lengthy in nature, because in the gate examination highly conceptual questions are asked, right? Any question can be done in very less steps, and if you are a good circuit analyzer, right? So let's move on. So this will be the lecture number 3, guys. Sorry, lecture number you can say 2, okay, on network theory, right? On network theory or circuit theory, or we call it basic electrical circuits, right? So last time we discussed about capacitors, so I will recall again. The capacitor was nothing but a parallel plate capacitor, right? So how this, in people who are from electronics background, they might be familiar with the MOS capacitor, right? In case of MOS capacitor, you take a look here. There are three material: metal, oxide, semiconductor. But what capacitor we are talking here is this is a capacitor basically. This is a symbol of the capacitor you see, and this is C here. The size of the capacitor will be always specified in terms of microfarad or in terms of femtofarad. Okay, these are the units, right? Femtofarad, okay, microfarad, okay, like this, millifarad, whatever say. So these are the size of the capacitor. Along with that, they will also specify the voltage, okay, how much voltage this capacitor can bear, right, or withstand. That is called the breakdown voltage. Based on that, also question has been asked, right? They have connected capacitor in series and parallel. Then they ask you that how much voltage we can apply across this entire system, right? So I will tell you the right strategy, to attack to these kind of problems so that you can solve it, right? So these kind of unit you will come across when we talk about capacitors, right? So this is going to be a I, okay? Current direction is downward, it is entering from plus to minus because, as far as the C is concerned, this is a passive element, right? Okay, please remember this. Yeah, hi, Ravi Teja, good afternoon and happy Diwali. Thank you so much for basing, right? So we have seen that naturally we know that what is the relation between I versus V. So C dV C by dt, right? So this dV by dt is nothing but the initial rate at which your capacitor is going to start charging, right? So when current flows through the capacitor, you have to keep in mind that then the capacitor will charge. And if you try to find the voltage, okay, if current is given, so that is going to be 1 by C minus infinity to T, you can say V I dt, right? Okay, so if there is a differentiation, so you should know this is going to be an integration, right? So this is the area under current curve, you can say. If current graph is given, current versus time, so you have to divide by C. The area should be divided by C in order to get the voltage. I can give you this kind of picture. Suppose this is the current curve they have mentioned here, right? And you can say from T0 to T1, right? So this is the area, okay? Suppose this is I versus T, right? This is the area. You can say area upon C will give you what? The voltage across the capacitor, right? So voltage will start from you can say the initial voltage. Suppose initial voltage is there, right? Your capacitor is initially charged, you can say. In the question they will always specify the capacitor is initially uncharged, or you can say initially at rest, okay? So you have to consider the voltage across the capacitor is 0. But suppose they have given they have said that the initial voltage across the capacitor is given. So please consider that, right? You can say at T naught, okay? So this voltage is at T naught, and this voltage you can say at, T1, right? So this is the difference. You see here, this is the slope, okay? Okay, that is going to define voltage versus T, right? So this is the difference. You see initial voltage is this, and the final voltage you can say at T1, right? So this slope we can find and multiply with the capacitor, so you will get the current, right? So I hope this makes sense. So this is all about capacitor, and capacitor can also be calculated. Suppose any geometry is given, right? This kind of a geometry. Though in electromagnetic theory, okay, we always discuss different types of geometries, like coaxial cable is there, sphere is there. So how do we compute capacitors? So there we use the concept of distribution of charges, and we use the Gauss law, and we can compute the capacitance, right? Okay, using some electromagnetic mechanisms, right? So this is D here, and it has the area, the plate area has got like this plate has got area A. Okay, I hope this makes sense. And the permittivity of this, the separation between them is, there is some dielectric. So you can say capacitor is nothing but epsilon A by D, right? Epsilon A by D. This is also one of the definitions that you have to remember, okay? But in case of MOS capacitor, you will find that in case of MOS, these two plates are metal only, right? Metal, metal. These are two conductors. But in case of MOS capacitor, you see there is one, you can say metal, then there will be oxide, and there will be a semiconductor interface. You can say this is going to be a semiconductor interface. This is going to be your oxide, and this will be the metal. You can say metal, oxide, semiconductor. So this is very interesting MOS capacitor, right? One of the very interesting MOS capacitor, which is very important to understand MOSFET, okay, metal oxide semiconductor field effect transistor, right? So I will teach this topic also when I will start devices, right? Fine. So you have to keep in mind what regarding capacitor, guys. Regarding capacitor, what you have to keep in mind is, if the current flowing through the capacitor is finite, okay, if I is finite, you can say, if I is finite, always remember, okay, then capacitor does not allow abrupt changes. The voltage of the capacitor is not going to change abruptly, right? Voltage does not change abruptly, you can say, right? This is very important information that I have told you, right? But suppose one capacitor is there, one more capacitor you're connecting, right? So if you want to charge the second capacitor, suppose first capacitor is charged, second capacitor also has to charge. You have to flow infinite current, otherwise your capacitor will not be able to charge, right? So infinite current is there. One of the question was there in GATE 2012, right? And that paper was, many people consider that paper was very difficult paper, and topper marks was, he's my mentor. In fact, I will disclose after GATE examination who was my mentor. He was the topper. Basically, he got 67 marks out of 100, and because of him today I am here, right? You can say, right? Because he gave me the initial belief that yeah, I can do something, okay? So he was the topper of 2012, and he got 67 marks out of 100. So I'm not revealing his name at this moment, but in all the video you will find his name, right? Whenever I will give some sort of my journey interview, right? So please remember this. तो ये याद रखना हमेशा, ठीक है? तो उस क्वेश्चन में क्या था कि this was a capacitor, you can say, and this was a capacitor. Two capacitors are connected like this, and there is a switch. Okay, so they are saying that some voltage is there, you can say 2 volt across this capacitor. So what will be the voltage across this capacitor? Okay, like if you want to like charge this capacitor, you can say this is C1, this is C2. So once this switch is closed, right, so what kind of current should flow so that this capacitor will immediately charge, you can say abruptly charge? Otherwise what will happen? There will be a violation of KVL. I will talk about different connections like series and parallel connections. Okay, so in parallel voltage should be same always, right? And the charges, whatever charge is here, right, the same amount of charge should also be here, okay, so that the KVL should not be violated, right? So in parallel charges will be equal. Suppose two capacitors are there, okay, and this guy has Q1 charge, you can say, so this guy will be having Q2 charge, so you can say that Q1 should be equal to Q2, right? This is very important to keep in mind. This is called charge conservation also, you can say, right? So suppose any capacitor is there, if you suddenly connect the battery across the capacitor. So don't expect that the capacitor will charge immediately if there is no infinite current, right? The infinite current should flow always through the capacitor, and these concept will be useful when we will talk about RC circuits, right? RC, RL circuits, RLC circuits, right? The first order, okay. Oh, Tomby, how you know, man? How you know, man? Okay. So, Tomby, what's your real name basically? I'm not able to identify your real name, right? So, yeah, fine. So, I will be revealing his name. Today only I talked and he appreciated a lot, right? He saw my intensity. In fact, he was saying that uh, people who are in my team, they are just having fun in their home, like, as work from home is going on. But looking at you, they are not, in fact, 10% of you, right? This kind of appreciation I got. Oh, Tomby saying Google. Yeah, great, great, great. So today only I had a chat. Every Diwali I talk my mentor, who is my real mentor, right? I mean, you can say. So the mentors can be anybody, right, in India. Okay, fine. So we will discuss later about this. Let us make our fundamentally strong first, right? So I hope this makes sense to everybody. So this is all about voltage and the capacitor capacitor concept, right? So you have to remember this, right? So let us talk about inductor now. So inductor is what? Inductor is also a two-terminal device. Okay, so this is the symbol of the inductor. Please remember this, and the current is gonna flow through this inductor, and the voltage across this will be V, you can say, right? And the L is going to be inductance of the inductor, right? Okay, so what is the relation here? Relation is basically what? Relation, the way current is going to be, right? Current is what? In case of capacitor, I is equal to dq by dt. So in case of this, we talk about voltage, right? So voltage is going to be d psi by dt, right? D psi by dt. Okay, this psi is nothing but a flux linkage. Flux linkage, okay, flux linkage, okay. So in this case, if the voltage is finite across this inductor, current cannot change suddenly. Okay, fine. So yeah. So you see, guys, this is, and what is this flux linkage? Flux linkage is going to be basically, since current is flowing through the inductor, so this current will be linking through these, these binding, coil. So there will be L times I. This is the flux linkage that you have to understand. Psi is going to be Li, okay? And if you plug this, okay, if you plug this, just like you always try to understand from the capacitor concept, Q equal to CV is there. In this case, I is equal to dq by dt, right? So always manage the parallel, okay, between inductor and the capacitor, right? In case of capacitance, voltage cannot change suddenly if there is a finite current, okay? You should know the reason always, right? And if there is a finite voltage here, right? So this guy cannot change, like current cannot change. So here initial will be the current, initial current will be there. You can say state variable, okay? Sometimes we call it state variable. Through the inductor, state variable is going to be current. In case of capacitor, state variable is going to be voltage, right? State means some sort of initial conditions I'm talking about, right? Okay. So here the relation is going to be L di by dt. If you plug this, okay, this guy here, okay. So this is the important relation that you have to always keep in mind. Please remember, okay. Okay, and inductor is always expressed in terms of Henry, right? So L is again the proportionality constant, you can say, and this is nothing but Henry, H, right? Henry. This is the inductor, okay? Inductor, fine. So I hope this makes sense to all. Okay, so this is very, very important. So if I further go on and take this voltage current relationship, okay, so V equal to L di by dt, right? So what is this current? I is going to be 1 by L V dt, right? So we always express, we always integrate this guy from minus infinity to the present time t, you can say, right? So if initial current is 0, sometimes what they will say that the inductor has no initial current. So you have to take initial current is 0. Please remember that, okay? So I'm just going to take, you can say that suppose I want to find current at t1. So we can find 1 by L T naught. We'll start with T naught to T1 V dt, right? Okay. So area under the voltage upon the inductor is going to give you the current at that instant, right? Okay, so please remember that this is very important. So if you want to include here plus I times T naught, you need to include this initial current, right? Please remember, okay? This is very, very important. This is very, very important, okay? So I T1 1 by L T naught to T1 V dt plus I T naught, right? I T naught, you have to add it. Okay, I think this is clear. Now we will talk about mutual inductance or mutual inductor, you can say. So this is going to be a simple IV relationship. Please remember this. Okay, this will be very useful in future. Okay, while solving RC, RLC, and RL circuits. What is this mutual inductor? So in case of mutual inductor, what will be there? There will be two inductance. Okay, right? You can say one inductor is this and one inductor is this, right? Okay, one inductor is this, these are the self inductance, you can say L1 and L2. Okay, these are the self inductance, right? So if this is a two terminal device, so one current is going to be and one voltage is going to be, right? As we know that if n terminal device is there, so how many current and voltage we can have? N minus 1. If it is a two terminal device, so one current, one voltage. In this case also you can say one current and one voltage, right? So here the current is flowing I2 and this is going to be V2, right? Okay, some sort of connection you might have seen, like when you talk about magnetically coupled circuit. Okay, so here also the same story is going to be. Now if I talk about flux linkage in case of first inductor, right? Okay, if you place one inductor adjacent to the another inductor, so there will be a flux linkage in the first inductor, you can say. Okay, L times, you can say L1 times current plus there will be what? There will be mutual inductance between L1 and L2, right? Okay, so that will be M times L2, right? This is the total flux linkage is going to happen in the inductor 1. Okay, and you can say that psi2 is going to be what? L2 times I2 plus M times I1, right? Please remember these things. Okay, so these are L1 and L2 are what? Self inductances of the coil 1 and coil 2, and this M is nothing but mutual inductance between L1 and L2, right? So now you can express V1, right? So you can say that this psi1 is nothing but V1. You can say that you can write here V1 is nothing but what? L. You can plug this, right? What is this voltage? Voltage is nothing but rate of change of flux, V equal to d psi by dt. Right? So now you plug this psi here, right? Many people get confused, right? How we write the equations of voltage and current in case of mutual inductance or mutually coupled circuit. So this is how we write. First of all, we need to understand what is the flux linkage happening in the first self inductance, okay, L1 or L2, right? Many people ignore this, but please take down, right? This is the right way of learning. Okay, so you know that this is the situation, so we can say that let me copy this guy and write okay, and by inspection you should learn, right? By inspection, okay, whenever you see the kind of mutually coupled circuit, though in electronics this guy is not in the syllabus, but for future reference, when you will go for placements and all, so they will certainly ask questions, right? So V1 is going to be what? L1 di1 by dt, right? L1 di1 by dt, okay, plus M di2 by dt, right? And V2 is going to be what? V2 is going to be L2, or you can say M, okay, you can say that M di1 by dt, okay, plus L2 di2 by dt. So this is the equation that you have to learn. How I have written this equation? I have written this equation as we know the flux linkage happening in the self inductance and flux linkage happening in the L2 and L1, right? And there is a mutual inductance between L1 and L2, right? So in your exam in the circuit they will mention like this, there will be M, right? So now since these currents are entering to this inductor, right, so there is a concept called dot in convention, right? So that I'm not going to talk right for the moment, but dot convention is one of the very important thing that helps you write the equation properly with correct polarity, right? Okay, so I hope this makes sense to all. Understood? So please remember that. Now I'll talk about linearity, right? So linearity is one of the very important concept that is very important. So what is this linearity business? Linearity, right? Now the concept which I'm going to talk about is linearity. Okay, you will also study in signal and system. Linearity plays an important role everywhere, guys. Okay, though we have to, if we want some sort of advantage like amplification and all, we need some non-linear device. Okay, in fact in communication system also non-linear devices are there. Okay, when we talk about modulations, for demodulation purpose we go for non-linear devices. You might have seen these things. Okay, so always remember कि ये जो ब्लॉक में नॉन लीनियर डिवाइस दिया है तो उसका कुछ पर्पज है, देयर इज सम बेनिफिट, राइट? ओके, when we talk about diodes, VJT, these are all guys are non-linear devices, right? लेकिन we should also know that how to convert non-linear devices to linear devices. ठीक है, ये भी बहुत important है. ठीक है, so what is this linearity? Linearity is nothing but a kind of characteristic, you can say, that obey superposition, right? Okay, so it is a characteristic. Okay, any characteristic you can say that obey what? Superposition. Okay, and superposition is nothing but what? Here we talk about homogeneity, right? Homogeneity, right? And homogeneity as well as what? Additivity. Okay, homogeneity and additivity, these are the two things that you have to always specify in order to claim that, yeah, this element is a, okay, so homogeneity, and you can say homogeneity is nothing but multiplication by a constant factor, constant scalar, you can say, right? So let me take a simple example. Suppose you have applied V1 across any element and you're getting I1. You have applied V2, you're getting I2, right? So if that element is a linear, you can say linear element, so that will follow like alpha times V1 plus alpha times V2 is going to be giving you alpha times I1 plus alpha times I2, right? Okay, so this is very important, characteristic that you have to always obey. Okay, I think this is clear, right? So V1 giving you I1. Okay, so V1 is the input, I1 is the output, you can say. V2 is input, I2 is the output. Then alpha times V1 means what? You are multiplying with alpha, means that is homogeneity. Okay, so linear system means zero input should lead to zero output. If you are applying zero input, so that should give you the zero output, right? Otherwise that system is not going to be linear. जैसे आप you take any circuit, right, and suppose your capacitor is initially charged, right? So that is not going to be a linear system. Okay, so okay, that is very important to keep in mind. And suppose you are writing a loop and there is an independent source present, right? So that is again not a linear circuit, right? So please remember all these things. Okay, so I will talk about linearity for each element. So this is the way we analyze linearity, right? Okay, so let us take one basic element, electrical element, that we call it resistor, and let us try to examine the linearity, right? So you know that this is the basic element. Okay, like this is V. Okay, and the current is flowing I according to passive sign convention R, right? And the relation between V and I is nothing but V equal to IR. Okay, now let us apply linearity. Okay, let us apply linearity. You can say that V1 is equal to I1 times R, V2 equal to I2 times R, right? You can write like this. Okay, now what you do, you plug in place of current alpha 1. Okay, like you can say that V equal to alpha I1 plus beta I2 times R, right? So you can write this as, this should be coming out to be V1 plus V2. Let us see. So alpha times I1 R plus beta times I2 R. So certainly this is nothing but alpha V1 plus beta V2, right? So this is satisfied. Okay, this is satisfied. Okay, please remember this. So we say that this guy is nothing but linear element. Okay, linear element. Okay, so always remember, now it is a basic truth that you have to accept. Okay, in the exam you don't have to examine. Okay, because now we know that resistance is one of the memory less element. Okay, it does not store anything, it simply dissipate power. In future you will come to know that resistor is one of the dissipative element. It is power hungry, you can say. It always eats power, right? Okay, so it always absorbs power. Keep in mind this. Okay, so this is how we examine the linearity, right? This is how we examine the linearity. Now let us take voltage source, right? If you take the voltage source here, and if I say that voltage source is linear or non-linear, right? So please remember, okay, voltage source I'm talking about ideal voltage source, right? This is the voltage source, you know. It says that I'm going to maintain the terminal voltage. Current is I here, okay? So whatever current flows through this, it is going to maintain always the terminal voltage, that is V naught, okay? So if you're going to, you can see from the IV characteristic, you can claim that this is non-linear, right? You see, this is I versus V, right? So this guy is nothing but V naught, and this is non-linear, okay? Directly you can say this is non-linear, okay? But you can prove it, okay? So you can say that if you change I equal to I1 and you say I equal to I2, whatever current you are changing, but voltage, ideal voltage says that I'm gonna be maintaining my specified voltage, that is V naught. So you will never get any other voltage, right? So it is what? Now if you take like alpha times I1 plus alpha times, you know, I2, sorry, beta times I2, right? Okay. So it does not follow what? It does not follow, okay, like alpha times V1 plus beta times V2, right? Okay, it does not follow. Okay, please remember. So you have to say that it does not obey linearity, right? Or you can say it does not obey superposition, so it is not linear, right? So this does not follow or obey, you can say, superposition. Okay, superposition. So it is not linear. Not linear. Please remember. So if this guy is present in the network, okay, if this guy will be present in the network, suppose you take the black box and this guy is present. So you say that it is non-linear system, right? So this is very important to keep in mind. Let's move ahead quickly. So now current is also non-linear, right? Because whatever voltage you're changing, your current is not going to change. So current source is also not linear, right? So you just keep in mind these concepts, right? So current source is also, you see, and this is the current source. Current source says that I'm not going to change, okay? Like if you connect voltage here and the current is flowing I naught, so it says that I'm not going to change. You see here, this is I naught versus V, right? I versus V characteristic. So you know, these, see, if you apply V1, if you say V2, so here same voltage current is there, right? Current is not going to change, so it is highly non-linear, right? Highly non-linear. It will not satisfy superposition, okay? And now from the IV characteristic, you can better say that, you know, you can better claim that, yeah, this element is non-linear, linear, right? So suppose IV characteristic is given, so you can better identify. You don't have to do these mathematics, whatever I'm doing, right? So suppose in case of resistor, if I talk about, okay, so in case of resistor, it follows the Ohm's law, right? So V equal to IR. So this straight line is going to pass through origin, right? So I versus V, you can say. So if this is going to pass through, this straight line is passing through origin, so keep in mind this is going to be linear, okay? Because zero input should lead to zero output. If there is a zero voltage, current is gonna be zero, right? Okay, so zero input should lead to zero output. So homogeneity is gonna be satisfied. Please remember, okay? So that element is gonna be linear, okay? Understood? So this you have to always remember, a straight line passing through origin, right? Certainly it will be passing through origin. It will be linear always, right? Linear. And suppose any line, any straight line, piecewise, whatever, right? So in case of voltage source, if you talk about, right, so the situation is like this, I versus V, right? If I talk about current source, I versus V, तो ये ऐसा होता है, current source and the voltage source, right? They are not passing through origin, you can say. They are not linear, right? So please remember this. Now let us talk about capacitor. Capacitor is also linear element, guys. I could not verify here, right? So you guys can always keep in mind capacitor. You guys can examine. This is the homework, you can say. Capacitor and inductor. Okay, these guys are what? Linear. Kab? When initial current is zero, right? So please remember this, okay? Initial current and initial voltages will be zero, then only you can say that capacitor and inductors are linear elements, okay? That is very important condition, right? When they are initially relaxed, right? Okay, initially relaxed. So these words are very important because At the end of the day, you might be aiming for ISC, you might be aiming to get into Texas or big companies, right? So these terminologies are very important. Okay, understood. And quickly we can verify also. If you take like if you want to verify the capacitor linearity, so you should recall C dV by dt, right? And you plug here. Okay, like if you plug alpha times I1 plus alpha times I2, so it should give you alpha times V1 plus alpha times V2. Okay, that should satisfy. So you try to plug here. Okay, you will get it. Okay, so in case of this, you can say I1 is going to be C dV1 by dt, I2 is going to be C dV2 by dt, right? But now if you plug here C dV by dt, sorry, in place of V you plug here what? Alpha times V1 plus beta times V2. So it should give you alpha times I1 plus alpha times, okay, so okay, alpha times V1 by this, beta times okay, so this is what? This is I1 and this is I2. You can say that alpha times I1 plus alpha beta times I2. So you can prove for inductor as well. Inductor के लिए क्या करना पड़ेगा? V equal to L di by dt से you can prove it, right? You say that for V1 there is L di1 by dt, for V2 L di2 by dt, then you put in place of I alpha I1 plus beta I2, and you will find that yeah, it holds superposition, right? So inductor and the capacitor both are linear devices when they are initially relaxed. This is very important statement. Please note down this. Okay, many people, suppose in the interview they will ask you, can you justify, can you examine the linearity? So आप ऐसे देखते रहोगे, अरे सर ने तो बताया नहीं था, राइट? तो वहां पर फिर आपको भगा देते हैं, भले आपकी रैंक 10 है 20 है कुछ भी है। इंडियन इंस्टीट्यूट ऑफ साइंस बैंगलोर में ऐसा हो रहा है, ठीक है, कि अगर आप वहां चुप हो तो बीइंग साइलेंट इज नॉट गोइंग टू गेट इनटू आईएससी, राइट? रिमेंबर, ओके? तो आपको अगर आपकी रैंक आती है फ्यूचर में, अच्छी रैंक आती है कि 180 रैंक, ओके, कुछ भी रैंक आती है 200 300, आजकल 300 वाले भी गेटिंग इनटू आईएससी एंड दे आर मेकिंग 40 लाख 50 लाख इन इंडिया, राइट? ओके, तो आप एक बार एंट्री करोगे आईएससी आईआईटी में, आपकी लाइफ सेटल है, राइट? फिर वहां पर कोई नहीं बोलने वाला। तो ऑलवेज लर्न फ्रॉम द एक्सपर्ट, राइट गाइज? उनसे मत पढ़िए जो आपको कैसा पढ़ाते हैं आपको समझ में आ रहा है, राइट? क्या मैं बोलना चाहता हूँ, ठीक है? तो ये रियलिटी है, रियलिटी सीखो, आप कोई भी क्वेश्चन कर पाओगे। अब डायरेक्ट कुछ लोग क्या करते हैं, दे टेक क्वेश्चन एंड दे वेस्ट देयर टाइम। अरे यार, तुमको कॉन्सेप्ट नहीं क्लियर है, कैसे क्वेश्चन सॉल्व कर रहे हो? दैट इज अ क्राइम, यू नो, इफ यू डोंट नो द क्वेश्चन कॉन्सेप्ट एंड यू सॉल्विंग द क्वेश्चन, राइट? तो ये कॉन्सेप्ट आपको क्लियर होना चाहिए लिनियरिटी का। ओके, सो लिनियरिटी इज वन ऑफ द वेरी इंपॉर्टेंट characteristic that should obey superposition, every element. Now we will talk about some of the elementary connections, right? Elementary connection means we will talk about series and parallel connections, right? These are the, we call it elementary connections. Okay, elementary connections. Okay, just like in signal we talk about elementary signals, you know, frequently encountered signal like unit step, impulse signal, ramp. Okay, the way here I'm going to talk about elementary connections, because after all we have to design, we have to make circuits, right? So you know, you should be familiar with elementary connections. Okay, so whether you are in India or anywhere, you have to follow this, right? Okay, so what will happen here is that, suppose this is going to be a black box, and this black box contains all sort of electrical elements. You can say resistance, voltage source, capacitor, inductor, right? So what you're going to do here is you will take out these two terminals here, and you will apply here the voltage, right? You're going to apply the voltage here, you can say at A and B terminals, and you're going to measure the current, right? Okay, so first of all, what is your job here? Okay, in these kind of elementary connections you should be able to determine IV relationship. So कैसे आप IV relationship find कर पाओगे? Okay, suppose this is a black box, voltage is connected, I is flowing, right? How can you find out the relation between V and I? So you need to do some algebra, okay, and then you can draw the IV graph, right? So please always be ready, and always be ready to do all these things. Okay, you should always go for IV relationship. Okay, how can you find the IV relationship? You will apply some sort of KVL, KCL, so many equipments are there जो हम लोगों ने पढ़ा है, तो आप आराम से कर पाओगे, ठीक है? So what are those elementary connections? What are those elementary connections that we have to talk about? So द वेरी फर्स्ट एलिमेंट्री कनेक्शन इज नोन एज सीरीज कनेक्शन, ठीक है, आपको याद रखना है सीरीज कनेक्शन. नाउ इन केस ऑफ सीरीज यू कैन कनेक्ट वोल्टेज सोर्सेस इन सीरीज, you can connect current source in series, you can connect resistances are in series, okay, inductor, capacitance, so all the electrical element you can connect in series, right? Okay, so this is the very first series connection, okay, and these connections are also in analog circuit, okay, wherever circuits are there, these initial, these connections will be always survive, right? So series connection mein kya hoga, what you have to keep in mind, we will take two elements and we will join them with some node, right? So you can say that in case of series connection, okay, two terminals basically we will take, okay, so you can say series connection of two or more than two terminal elements, right? Okay, series connections of two or more than two terminals, right, elements. तो मान लो आपके पास एक रेजिस्टेंस ऐसा है and then we are connecting like this. Suppose this is one resistance, you can say, and this there is second, you can say this is A resistance, this is B resistance, okay. So if I ask you what is the current flowing through these, okay, so you see here this is the node here, okay, as I told you element itself is a branch, right? Branch is nothing but what? Element, right? There should be one element, then you can say this is going to be a branch, right? So if I ask you what is the current flowing through this resistance A, so that is I, okay, understood. If somebody will ask what is the current flowing through this current this resistance B, same, okay, and suppose any other element is connected here, so same current is gonna flow, okay. So when the elements are connected in series, guys, always remember, Zombie is asking when signal and system will be started. Very soon after network, signal is going to be there, and I think once you will get to see my signal sessions, you will say that, oh ho, you are making mistake, you are wasting your time on somewhere down the line, watching some YouTube or paid courses anywhere, right? Okay, so that's what I can promise, right? So wait for that, it is coming on the way, everything is on the way, let me conduct, right? ओके, सो सब कुछ आएगा, अब आपको धीरज तो रखना पड़ेगा, राइट? ठीक है, तो अब देखो ये एलिमेंट्री कनेक्शंस में सीरीज में अगर आप दो रेजिस्टेंस को लगाते हो बहुत सारे, ओके, तो इसमें क्या फोकस करना है, तो इसमें ये फोकस करना है कि सेम करंट फ्लोज इन द टू टर्मिनल, राइट? ओके, सपोज एलिमेंट ए इज देयर and which is connected to terminal of element B, okay, so this is how we make series connections, right? So same current flows in these three elements, you can see, right? The same current, okay, flows, okay. So in case of series, remember always same current, okay, we don't talk about voltage here, same current is gonna flow, right? Don't say that same current is not going to flow, right? So if anywhere you see, anywhere, many times I always say people, right, suppose this is a op-amp, let me take here, right, and this is going to be any kind of op-amp, right? I'm not going to talk about any particular name or something. Suppose 10 volt is there, and this is the resistance connected here, right? You see, now what I say that this is R1, this is R2, right? Okay, now if op-amp does not accept any current, everybody knows, क्योंकि op-amp का जो infinite resistance होता है, input resistance होता है, that is very high, okay, ideally, so no current is there. So whenever I say that R1 and R2 are in series, you should always accept. Why? Because whatever current is flowing through this resistance, the same current is flowing through this resistance, okay. So accept it, don't say that, oh, okay, many people do not concentrate on it, they directly apply KCL, KVL and they waste their time, okay. तो आपको जब भी कोई क्वेश्चन आता है, यू हैव टू ऑलवेज फाइंड दीज एलिमेंट्री कनेक्शंस कि कहाँ सीरीज है. इफ सीरीज इज देयर, certainly current is going to be same, your life will become very easy, आप जल्दी से आंसर निकाल पाओगे, and I will show you, right? ठीक है, so this is the example that I have told you, right? I will talk everything, okay. So remember series में क्या होगा, same current is going to flow, right? Same current, okay. And if there is a series connections and you know the voltage across each element, you can say, right? Okay, you can say that suppose this is kind of a circuit, okay, suppose this is kind of a circuit, some black box you can, and you know the voltage across this black box, you can say Vx, right? Suppose you don't know the voltage across this Vx, you have just written Vx here, right? And all the elements are connected here in series, right? ऐसे series में connected है, ठीक है. Now you know the voltage across this Va, VV, and you know the voltage across this VC, right? In series, voltage will be different, right? Yes, yes, yes. Non-linear element will be present, so you have to say, right? So I will talk about wait, life is coming, okay? Your life is gonna get simplified. सारा डाउट आज क्लियर मैं कर दूंगा, सारे क्वेश्चन आप कर पाओगे नेटवर्क में, कोई ऐसा कुछ भी नहीं है, ठीक है? जस्ट वेट, ठीक है? हाँ, ब्लैक बॉक्स शुड बी, अब उसके if any resistances are connected around that, that is not non-linear, right? So you know, I can give you the example. See, basically we will talk about in future Thevenin theorem, right? So we talk about Thevenin theorem is applied for linear, okay, the circuit is linear, right? So we can take you one of the very important, suppose this is a diode here, and you know, these are the connections, okay, we have got, right? Okay. Now many people say that, oh, ये क्वेश्चन हम कैसे सॉल्व करेंगे? यूजिंग केवीएल केसीएल ओनली, राइट? ओके, व्हाई यू आर वेस्टिंग योर टाइम मैन? अब उनके माइंड में क्या रखा है? ओनली लीनियर सर्किट we can use Thevenin theorem, right? But you can simplify the network, guys, by using Thevenin theorem. And Thevenin theorem is nothing but what? There are two circuits connected between these two nodes, you can say between these two electrodes. You look back toward the network, you look back toward the network, right? And you simplify it, okay? Okay, and you enjoy, okay, you will get the answer in second, right? So simply you can apply here, let me specify this, I will tell you, right? You can apply the superposition here, Thevenin equivalent, Thevenin theorem here. You can Theveninize this guy, right? And once you have Thevenized, you can use the concept of whatever diode concept you have learned, and okay, so here the Thevenin theorem is applicable. But here, okay, suppose any black box is there and there is a diode connected, and then you are thinking that, yeah, can we use Thevenin theorem? No, right? So that black box should not contain a non-linear element, right? Otherwise Thevenin theorem and you know, superposition and all you cannot use, right? Please remember this, okay? So this is very important to understand. How do we calculate open circuit voltage? We need to look back to the network. The entire network should look like a voltage source, right? Entire network, a big network. You can say network from my home to your home, wherever you are sitting right now, right? So I should always see like this. Yes, VOC, RTS ऐसे देखना है आपको. You have to look back to the network. अब ऐसा नहीं है कि ओ सर ने बता दिया कि you have to open the load resistance and then it's okay, you will open it, but you have to look also, na? So when you will look back, you will see those elementary connections like series, parallel, you know. So you can further go on simplifying how to simplify series, resistance, parallel resistance. Life will become easy. नहीं तो आप जब केवल your concentration is at load only, right? And you're not looking like this. How can you find the RTS? How can you find the VTH? Okay, that is what people make mistake, right? तो क्योंकि आप तो उसमें फोकस्ड हो कि you know, the sir is teaching, sir is this sir, that sir, right? और बस आप भूल जाते हो अपना गोल. ओके, सो मैं इसीलिए बोल रहा हूं कि डोंट मिस द फॉरेस्ट, ओके, फॉर द ट्रीज. ये बहुत इंपॉर्टेंट लाइन है, आप याद रखना. ये किसने बोला था मैं आपको बता भी देता हूँ, ठीक है? One guy is there, right? He is a great guy, right? Who teaches analog well. So he says that don't miss the forest for the trees, right? तो आप लोग क्या होता है ना कि ट्रीज के चक्कर में फॉरेस्ट ही भूल जाते हो, अपना गोल भूल जाते हो, राइट? डोंट फॉरगेट, ठीक है? अब देखो यहाँ पर क्या है, these guys are connected in series, right? When one of the element is connected to another element, okay, you see here, ये series है, right? So now if someone is going to, what is this Vx? So if this is the series connection, so you can apply YKVL, right? You can easily find out this Vx. So Vx is going to see. Now this guy can be anything, right? Like it can be non-linear network, linear network, कुछ भी हो, है ना? मुझे उससे मतलब नहीं है. As long as we know the voltage across this, we can find the Vx. So minus Vx plus Va plus Vb plus Vc equal to 0, right? ये आ जाएगा आपका KVL. So Vx is going to be what? Va plus Vb plus Vc. So I think this is clear for all, right? So in case of series, remember, in case of series connections, the voltage will be different across each element, but current is gonna be same. You just note down these points, guys. This is very important. Now if you look at the gate question, you can simply solve it, right? There's no you don't have to waste. So you know, why we are saying that current is going to be same? Here you can also say that suppose some current is flowing here and some current is flowing, suppose I2 is flowing here, right? So if I1 and I2 are not same, so KCL will be violated, right? KCL, if any law is there, you know, in India, whenever any any law is imposed, right, so you have to follow it, otherwise क्या होगा फिर, है ना? So if law is there, you have to follow it. So you see I1 and I2, if they are not same, so KCL is gonna get violated, right? So you have to always keep in mind that current incoming to the node should be always be equal to current outgoing. So here I1 and I2 has to be same, right? Please remember, so that KCL will not be violated. Same current flows through these elements, okay? And the voltage across the ends of the series combination will be what? This Vx equal to Va plus Vb plus Vc, right? So this is the ending, you know, this is a point where the voltage, like the series connection ends. Now they will ask what is the voltage across this terminal. तो आप कैसे मेजर करोगे? In the lab you will connect one voltmeter and you have to make sure that the voltmeter has got high resistance, okay? Finite resistance नहीं होना चाहिए, नहीं तो फिर this series connection will become different, right? Okay, so high resistance रहेगा, so nothing is gonna happen, just you will get the voltage in the voltmeter, right? Okay, this is very important to remember. चलो ये story आपकी volt, please remember this. So if you connect any element, you can connect resistance, you can connect okay, so I did not talk about any element, just I talked about if there is a series connection, that is elementary connections, so current is going to be same and voltage is going to be different, right? Now we will talk about voltage sources. So you guys can always connect voltage source in series. Voltage source, okay, when voltage sources are connected in series, what is the meaning of that? Suppose this is kind of a circuit and you know the voltage across this, right? You have to measure it, sorry, okay, or you know also. So if you connect here the voltage here, like you can say V1 and this is going to be V2, right? Okay. These two voltages are connected in series, okay? Why we call it connected in series? Because the current is going to be same. Now if someone is going to ask you what is this Vx, you should be able to apply KVL here. Again you say that, and I told you how to apply KVL. I have told you how to apply KVL. KVL is nothing but what? The voltage drop, right? And here the voltages are given, okay? You take V minus V2 minus V1 plus Vx equal to 0, right? So you say that Vx is going to be V1 plus V2. Simple. And though these are the same, like, you know, across that, and this voltage you are finding across this series connection, so you know the voltage should be same, like addition of the two voltages, you can say, right? So people who are very good at circuit analyzing, okay, like who has taken my classes, so they are really expert. They know that where we have to use KVL, where we have to use KCL, how we have to use KVL, how we have to use KCL, कहाँ थ्योरम यूज करना है, कहाँ, तो उनके माइंड में ये नहीं रहता कि यार लीनियर है तो सुपरपोजिशन नहीं लगाएंगे, नॉन लीनियर है नहीं लगाएंगे. अब ऐसा नहीं है यार, ओके, प्लीज ओके, नॉन लीनियर है, आई कंसीडर यू कांट अप्लाई सुपरपोजिशन, बट द थिंग इज ओके, डोंट बी अर्जुना इन दैट केस, राइट, कि अब बस आप डायोड को देख रहे हो, ओके, यू ऑलवेज लुक दिस साइड आल्सो, राइट. If anything you are looking kind of a linear things, right, if you're looking kind of a linear things, you can apply superposition. Okay, suppose you have replaced the diode by its equivalent, or you can say by its cut-in voltage or something, then you can also apply superposition, right? क्योंकि अब वहां पर तो diode is gone, right? Okay, please remember. So I will talk about that. Okay, so this is how we can say. So if you connect n number of voltages in series, okay, and then you're going to measure the voltage across that series and where series connection ends, right? So summation of all the voltage you can do, right? All, you just add all the voltages. So always remember this. So suppose here so many voltages are connected, V1, V2, V3, right, and so on, Vn, right? And suppose you are finding the voltage across this. Okay, so this is plus minus plus minus plus minus plus minus. Okay, any of the voltage polarity is going to reverse. आपको ये notice करना है, in gate examination they sometimes reverse the polarity, right? Okay, so people are crazy about somebody, right? कि okay, sir has told me this, so life is that only, right? फिर marks आया कितना, वही क्वालिफाई भी नहीं हुआ, राइट, ठीक है. So that is very important to understand naturally. So you have to notice everything. So if all guys are having the plus minus plus minus plus minus, so you can say that you just add them, right? So that will be summation of all the voltages. You can say vi I equal to 1 to n. Okay, so I think this is clear. This is very very important to notice. And then we will talk about current sources. Ab dekho, current source, if you are connecting in series, right, current source. Okay, current source, if you're connecting in series, okay, so you have to keep in mind some points, right? What are the points that you have to keep in mind? The KCL should not be violated, guys, right? Suppose you are connecting current, like this is the current I1 and there is a current, you can say I2, right? And this is a node where you have to check whether KCL is valid or not, right? Suppose I1 and I2 are different, then what? Not permitted, guys, not permitted in series, remember. Okay, why not permitted? Because KCL at this point is violated, and we don't want any law to be violated, right? We don't want any law to be violated, so you cannot apply I1 is not equal to I2, right? That is not permitted. Okay, if I1 is equal to I2, so you can simply reduce this guy. Okay? You can simply reduce this guy to, you can say that this is nothing but I, okay, which is I1 plus equal to I2, right? Okay, because in series the currents are same, so single, okay, suppose many currents are connected in series, many current sources are connected in series, so you can always replace it by single current source. Okay, please remember this, if all currents are same. Agar question may by mistake, like many people nowadays, in test series and all, they try to show their billions, okay, so they might connect okay something, right? तो आप लोग फिर शेयर कर दोगे सोशल मीडिया में कि सर यहाँ पर डाउट है ना. You're not thinking by yourself, right? And you're sharing, अरे वो question ही wrong है, right? So you have to think all these things, right? Which circuit is correct, which circuit is wrong, okay? चलो. Now let us connect resistance in series, okay? In case of resistance in series, what will be the effective resistance that you have to remember, right? So suppose there are three resistors in series, okay? Suppose these three resistances are connected, you can say it R1, R2, R3, okay, and the current is going to flow here, same current I, and you can pick up the voltage V1, V2 and V3, right? V1, V2, V3. I think this is clear. So V1 is going to be what? V1 is going to be I times R1, V2 is going to be I times R2, V3 is going to be I times R3, right? Okay, so if you add all the voltages, right, if you add all the voltages, suppose you want to find here the, you want to find Vx here, right? So what is this Vx, right? So you can say that this Vx, or you want to find here the R equivalent, you can say. So you have to apply one Vx here, and the current should flow Ix, you can say. The ratio of Vx and Ix will give you the R equivalent, okay? So you know that I will talk about that also, how to find R equivalent, okay? You have to look back to the network, okay? And all the resistances are connected in series, so you add them. Kaise? Vx is equal to V1 plus V2 plus V3, right? So Vx is going to be, you can say that I times R1 plus R2 plus R3, and this I is nothing but Ix, so R1 plus R2 plus R3, and the ratio of Vx by Ix is nothing but what? Sum of all the resistances, right? So suppose there are many resistances, you can say n number of resistances are connected, so you have to add them, right? R1 plus R2, or suppose all the resistances are same, so you can say that n times R. Okay, in case of series, it is very simple to understand, okay? Sum of all the resistances and capacitance if they are in series. So while applying the concept of this, like while finding the C equivalent, you have to make sure that these capacitance are initially uncharged, right? I mean, there is zero initial voltage. ऐसा नहीं है कि there is an initial voltage, then you can combine. No. So capacitor in series, okay, the capacitor in series, right? So these things are very important, right? So zero initial voltage, it is important condition. People miss it, right? Nobody knows this, okay? So directly people take that, suppose this is C1 and this is C2, all right? and the current is going to be flowing I1, the voltage across this V1, V2, right? So again, if you want to find C equivalent, you have to apply, that is very important, right? Or you can say that you can apply linearity here, right? Okay, the two voltages can be added, right? Okay, so this will give you what? You will always get 1 by C equivalent. Let me not prove it, you guys can prove by yourself. 1 by C equivalent across this, right? 1 by C equivalent is going to be 1 by C1 plus 1 by C2. So here C equivalent is going to be C1 C2 by C1 plus C2, right? तो ये आपको याद रखना है कि whenever the capacitances are connected in series, okay, so your C equivalent will be just like, the resistance will be in parallel, right? R1 R2 by R1 plus R2. So here you have to understand this, okay? So C equivalent is gonna be this. So you guys can prove it. I need not to prove, okay? How you can prove it? You know that V1 is going to be 1 by C1 times I dt, integration I dt. V2 is going to be integration I dt. Then okay, the current is same, so 1 by C1 plus 1 by C2 is going to be that. Okay, now if there are n number of, you can say n number of capacitances, many people are only restricted to this. मान लो वहां पर बहुत सारे capacitance connected हैं series में, 1 2 3 and so on. Now you have to find C equivalent here, C1 C2 C3. Don't worry guys, don't worry, always use this formula. 1 by C equivalent is going to be 1 by C1 plus 1 by C2 plus and so on plus 1 by Cn. Okay, don't use that. Okay. Understood? Don't use the C1 C2 by C1 C2, okay, for two capacitance, right? Always keep your horizon to the infinity, right? Okay, so agar 1 by C1, right? 1 by C1, then you want to find C equivalent, so you just take the reciprocal of that, right? Okay, so this is very important to keep in mind. So that will be C effective, you can say. Now we will talk about parallel connections, right? In case of parallel connections, I think many of you might be familiar. In case of parallel connections, that is second elementary connections, parallel connection. Okay. So suppose these are the elements which are connected in parallel, right? You see this is one element, you see this is second element, you see this is third element, right? And if you're going to connect here the voltage, you can say V. So this V is going to be same across, right? Now the V is going to be same, V is same here, right? V is same, okay? But the current which is flowing through I1, I2, okay, I3. So total current here is what? I equal to I1 plus I2 plus I3. Understood? So please remember this, okay? Understood? So this is very, very important to keep in mind. So current, if you apply the KCL, so that KCL should get not violated. So I1 plus I2 plus I3. I think this is clear. So in case of parallel, the voltage is going to be same, the current will be different, right? So from here you can say the current division rule will come into picture. And so can we connect two voltage source, two different voltage sources are in parallel? That is a question, right? So voltage sources in parallel, right? Can we connect them? Like, V1 connection with, parallel connection V2. Can we connect like this? No, right? If V1 is not equal to V2, it is not permitted, guys, right? So these two voltages should be same. V1 plus V2 should be, V1 equal to V2 should be there. Otherwise, it is wrong. Okay. Otherwise, it is wrong. Please remember. So connection is not permitted if V1 is not equal to V2, right? Not permitted, right? And suppose they are, suppose V1 equal to V2, so simply you replace it by one single voltage source. Okay, don't disturb the circuit here, right? Okay. And in case of current sources, suppose current sources are connected in parallel, so yeah, it is allowed, right? Different current sources you can connect in parallel and you can sum them up total, right? So I can show you, suppose there are n number of current sources connected like this, I1, I2 and so on. You can say that IN. Okay, in fact you will see that in case of transients and all, current sources are connected in parallel, switch is connected in parallel, inductor and resistance are connected in parallel. Okay, so your life is like, at that time people get confused, right? But I will tell you all the techniques, so you will see the question, you will say answer ही है, आपको solve ही नहीं करना है question को, ठीक है? तो आप जब क्वेश्चन को देखो तो आपको ये समझ आ जाना चाहिए कि यस, इसका स्टार्टिंग पॉइंट ये है, इसका एंडिंग पॉइंट ये है, तभी गेट में रैंक आएगी। ऐसा नहीं है कि आप क्वेश्चन देखे कंफ्यूज हो, तो आप सोचने में यू आर वेस्टिंग योर टाइम ऑन थिंकिंग। जैसे इंटरव्यू होता है ना, द सेम वे यू हैव टू अपीयर इन द गेट एग्जाम आल्सो, कि मतलब क्वेश्चन आया, यू शुड नो व्हाट इज द स्टार्टिंग पॉइंट, व्हाट इज द एंडिंग पॉइंट। ऐसा नहीं कि वहां भी आप प्रैक्टिस कर रहे हो तो लाइफ में बहुत टफ हो जाएगा। एंड द मिस्टेक वी डू, आई विल टेल यू, राइट। सो ये आई कितना हो जाएगा, I1 प्लस I2 प्लस I डॉट डॉट IN, मेक श्योर दैट ऑल गाइज आर गोइंग डाउन, राइट। या ठीक है। So guys, this is what I wanted to talk today. We'll meet in the next session, right? We'll talk about resistance in parallel, okay? Capacitor in parallel, inductor in parallel, okay? Then we will talk about series parallel combination of dissimilar element. अभी क्या कर रहे हैं? Similar element का series and parallel combination we are looking at. Similar means resistance, 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 voltage, voltage, voltage. But in future we will talk about, in next class you can see series parallel combination of dissimilar element. So you can expect today only the second class, right? I mean third class today itself, okay? So I will inform in the, like, after celebrating Diwali and all, we will meet again today itself, okay? Because I'm very hungry to deliver all the sessions for you guys, okay, so that you guys can revise everything, okay? So I think this was amazing. So what we will do there is series parallel combination of dissimilar element, where we will connect resistor and the current source in series. So we'll see that whether that resistance plays any role or not in the circuit, okay? That is very important, right? What is the equivalent of that? ठीक है, क्योंकि जब सीरीज में अगर करंट सोर्स है and one resistor is there, okay, ideal current source and the resistor, so you know that resistor does not play any role, right? Okay, in the circuit, so you can ignore that, ठीक है? So I will tell you next session today itself after celebrating Diwali, right? So we'll meet very soon. And remember guys, I'm streaming these sessions from Bangalore, right? So I need to manage many things, right? So yeah, we'll meet very soon, and I hope you might have enjoyed the session, highly energetic session, right? So enjoy your Diwali and happy Diwali again. We'll meet